I think that we are all here.
We're missing Isabella.
There we go. There she be. Thank you. All right, there's Isabella. So I think we're good. Okay, and there I am where I can see several of y'all at a time. Okay, so let's get back with what we were doing here. Okay, so here's this idea. I've looked from this, I've kind of estimated, and I'm able to see the fact that my answer is going to be somewhere between 3 and 4. All right, so on my calculator, so now I need to figure out how am I going to enter this right here on my calculator. All right. For mine, if I'm looking at the if I'm looking at a Texas Instrument, there's a button right here called Math, and I wanted needing to hit that Math button on the Texas Instrument. Okay, so I'm going to do that, and it has some different things that kind of show up there. All right, you see all these things that have shown up here on my Texas Instrument? All right, you see how if you go down to the 5th one, it's got that X and then the square root sign. So for me, I'm going to arrow down to where that is. I've arrowed down, and that's highlighted now. And so then what I'm going to do is hit enter so that I choose that one. Okay, and once I hit enter so that I choose that one, what's on my screen looks like this, and I'm able to key in a value into that flashing box outside the square root sign, and then I can key in a value inside there. So I'm going, I've got in the display, that one's flashing, so I'm going to put 3.28 there, and then on this, I have these arrow keys here, so I'm going to use that arrow key. And when I did that, it should, if I can find, yeah, it moved my flashing box to underneath the radical sign. So now I can enter a 50.42 in there. And so now I've got the problem. Okay, and then I can hit enter. And the answer that I get is 3.30435144.7. Aren't you guys glad that I can read backwards? I'm impressed. Yay, thank you, Ben. It's the little things in life. Okay, so that's what you're looking to do. So for you guys, there is figuring that out. Now the note that I have, okay, for a Casio, with a Casio, I would know that you hit shift and you've got a key that looks like this. Okay, and above that key, I think that there should be a picture that looks like this above, that's above that key. All right, and you're hitting the shift, and that's going to activate this right here that's above that key. Okay, so that's what you're doing with the Casio. With the Texas Instruments, I had to hit the math button. I arrowed down to number 5, which number 5 showed a picture. Actually, it might have just, what did number 5 show? Oh no, when you find number 5 on the Texas Instrument, it actually just shows like this. Okay, so I did that and I hit enter. And then at that point, after I hit enter, my display, and at this point, the Casio and the Texas Instruments, your display on both of those, I believe, should wind up looking like that. Okay, and this one right here should be flashing. So that way you can just go ahead and put your number into there. And then, so I entered the 3.28, and then I used my arrow key. And when I used my arrow key, then this one right here started flashing, and I was able to enter the 50.42. And after that, I just hit my enter key. And that gave me my answer. And that answer was 3.34. And it goes on and on and on. But all you need to give for an answer is just, you know, go out to that hundredths place. All right. I got a nod. Thank you, sir. Got a thumbs up. All right. So again, just kind of keep monkeying with that a little bit so that you can see how that works. Again, you might find that it's helpful to look at some stuff as far as some videos. Okay, last thing I'm going to show you on this calculator business, and then we're going to move on because I know this is kind of tedious. It is. All right, if you've got, say, 9.26, and this is going to be raised to this negative 4.58. Remember when I have that negative sign in front there, that's going to be in the reciprocal. Okay, so this is going to be 1 over, it winds up being 26,734.18. Okay, what this is looking at is 1 over 9.26 raised to the 4.58. All right. So with this right here, as I'm looking, you need to think about that a little bit. So as I look to put it in the calculator, I'm really just needing to put in there 9.26 and my little caret thing. And I can go ahead and do the negative 4.58. I can go ahead and put that negative sign in there. All right. And when you do that, the answer that you're going to get is going to be 3.74 times 10 to the negative 5. Okay. And just a comment here, this answer right here is the same if you also take this 1 over 26,734.18. If I take 1 and I divide it by that number, I get this same number, you know, just kind of as a check. You know, we're able to see the fact that we know this 9.26 to the negative 4.58 is equal to this right here. And that right there mathematically is equal to that right there, which this right here also equals 3.74 times 10 to the negative 5th. At the same time, if I enter this into my calculator, if I enter the 9.26 and you do the caret or however your calculator has you raise that, and you raise it to the negative 4.58, you're also going to get this 3.74 times 10 to the negative 5. Okay, I know this is not an exciting lesson. It's even less exciting when y'all are all quiet. All right, we're going to move on from this. All right, we're going to do something different. We're going to do something much more exciting. What we're going to do now is advanced abstract equations. Advanced abstract. That always sounds like fun. Actually, it's really not too bad. It's just moving stuff around. So we're going to go back to what you're used to. We're just going to move stuff around. All right, so this is going to be less than 70. All right, so I've got here solve for B. Solve for B is what we're told to do. And the equation that I have is X equals P, opening parentheses, 1 over A plus M over B. All right, so I've got this right here, and I want to solve for B. So I have to unbury B. Right now, B is inside parentheses and it's in the denominator. So we're just going to start moving stuff around. So let's first begin by distributing that P through so that I get X equals P over A plus MP, P, not a B, MP over B. So I've got that to begin with, right? And so now we're going to eliminate our denominators. Let's eliminate our denominators by multiplying everything by AB, right? And that'll get rid of my denominator. So I'm going to multiply this by AB. I'm going to multiply this by AB. And I'm going to multiply this by AB, right? Remember, when I do that, those A's are going to cancel out. And over here, these B's are going to cancel out. Remember that? Okay, so here I wind up then with ABX equals BP plus AMP. All right, so this is looking much better. So think about the first thing I did was I distributed, then I got rid of my denominators. Remember the fact I'm solving for B, so let's get everything with the B on the same side. So I have ABX minus BP equals AMP. This is looking good. Let's factor out the B. So I get AX minus P equals AMP. All right, and then we're just going to divide both sides here so that I get B equals AMP over AX minus P. Good. If this feels familiar, yes, we've done plenty of stuff like this before. All right, so as they introduced it again, it's like, okay, we can totally do that. All right, that is that for that lesson. So that was nice and easy. All right, now we're gonna move on to lesson 71. All right, lesson 71 is the quadratic formula. Are you guys all awake? Yeah. Okay, gotta be awake for this one, for reals. Even the kitty cat has to be awake for this one. All right, so here we go. All right, so let's think. We're going to use the quadratic formula in order to solve equations. All right, so think about the fact the way that we solve quadratic equations. There's two different ways. It's going to be if it's factorable, or if not factorable. All right, so there's two ideas. It's going to be something that we can factor. It's going to be something that we cannot factor. So say if I have x squared plus 2x minus 15 equals 0. All right, now look at the fact. Remember, I can take this, go and take my x, and I think about the 15, and what are the factors of 15 that I can add together and also get a 2? Those are going to be 5 and 3, okay? The 2 needs to be positive, therefore the 5 has to be positive and the 3 is going to be negative. So I can factor that, right? And so if I take this x minus 3 and set it equal to 0, x minus 3 equals 0, so x equals 3. Or I do this x plus 5 equals 0, so x equals negative 5, and my answer here is going to be that x equals negative 5 or 3, right? Easy. All right, if it's something that we cannot factor, that's when we're going to complete the square. Okay, so here if I have x squared plus 3x minus 3 equals 0, I can't factor it. So I'm going to take x squared plus 3x. I'm going to move that 3 to the other side. And I've got this blank space. Okay, remember I'm going to take that 3 from the middle right here. I'm going to multiply it by 1/2. And I'm going to square it, right? So that's going to give me 9/4. Okay, so I'm going to take that 9/4 and I'm going to plug it in on both sides. So I'm going to put a 9/4 here. and a 9/4 here. All right, now I can take this equation right here, you know, and I can factor it out. And I would get x and 3/2 and 3/2. And it's going to be the exact same thing, right? Over here, I would get a common denominator and add this up and get 21/4. Okay, I can rewrite this now as x plus 3/2 squared equals 21/4. Okay, remember the idea that I'm going to take the square root of both sides. So x plus 3/2 equals plus or minus the square root of 21/4. Okay, remember as you do this, this is something that there was a little issue on the test with a couple of people. Remember that this 4 right here, we're also finding the square root of that. Okay, so this winds up coming out to x equals -3/2 plus or minus the square root of 21/2, that 4 should become a 2 because you take the square root of the bottom. It's not just the square root of the top, it's the square root of the bottom also, okay? So that was something that there were a couple issues with on the test. Okay, so we remember how to do that. We've got those 2 different ways that we solve a quadratic equation. If it's factorable, we factor it. If it's not, we complete the square. Okay, and so what we're going to do here, through completing the square, we wind up deriving a formula that we can solve both types of quadratic equations. Okay, so what I'm going to do right now, I'm going to go through a process with you that's going to show you how we get the quadratic equation. You will have this as a homework problem, so go ahead and kind of take notes as we're going through this. All right, so here I'm going to have a basic quadratic equation. All right, if I have a squared plus bx plus c equals 0. All right, remember right here, oh, excuse me, this is ax squared. Okay, so look at this. I've got ax squared plus bx plus c equals 0. All right, what I want to do, I need to get rid of that a as the coefficient of x. So I'm going to divide everything by a in order to make that happen. Okay, so if I divide everything by a, I've then got x squared plus bax plus ca equals 0. All right, I need to solve this. So what I'm going to do is I'm going to complete the square. So I've got this x squared plus bax equals negative c over a. Okay. I'm going to take here with this ba, I've got this b over a, I'm going to multiply it by 1/2, and then I'm going to square it. Okay. So when I do that, the b a times 1/2 is going to give me b over 2a. And then when I square that, I'm going to get b squared over 4a squared. You guys see that? Okay. All right, so what I'm going to do is I'm going to take this now, I'm going to add this to both sides. B squared over 4a squared plus b squared over 4a squared. All right. I'm going to go ahead and erase this over here for now that we know how I got that. Okay, so now this right here, think about the fact that I can factor it, and the factors are going to be a perfect square. Okay. You guys good? Can y'all hear? Yes. Okay. Okay, so over here, as I factor this, it's going to be, remember, again, a perfect square, and it's going to be the b over 2a positive. Are you guys good with that? That the factors of this whole thing right here is just x squared times b over 2a. I've taken the square root of the b, the square root of the 4, and the square root of the 2a. And over here, I took the square root of the x, just like over here when I had this x squared plus 3x plus 9/4. The factors of that wound up being just the square root of the x and the square root of the 9/4. Okay. All right, so I'm back down here. So this right here is equal to this squared. All right, over here, if I take and I get a common denominator and I add this all together, I'm not going to work that out for y'all, but trust me, if you get the common denominator and you add this all together, you get b squared minus 4ac over 4a squared is what that winds up coming out to. All right, now I'm going to take the square root of both sides. So I'm going to get x plus b over 2a equals the square root of b squared minus 4ac over 4a squared. Okay. So let's move this right here to the other side now so that I get x equals negative b over 2a. All right. Plus, I'm going to go ahead and take the square root of the bottom so that only the top will be left up here with the radical sign still there. But the bottom, the square root of 4 is 2, and the square root of a is just that a. All right, so now when I combine those two together, I've got x equals negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. All right, this right here, you need to memorize this. Okay, this is the quadratic formula. Okay, all right, so that's the quadratic formula that you need to memorize. You do. You need to know that x equals negative b plus or minus the square root of b squared minus 4ac over 2a. You're going to use it a lot, but you really do need to memorize it, okay? And what we did there was we started out with a base equation, all right? And we've taken that equation and we've worked through completing the square. So now we've come down to this right here. And we're going to be able to use this by taking the numbers from any quadratic equation and plugging them into this and solving for x, okay? So that's what we're going to do next. All right, so I've got this quadratic formula. And now we're going to say solve 3x squared minus 2x plus 5 equals 0. Okay, remember we started off with that equation ax squared minus bx plus c equals 0. Remember, that's where we started. And we said that if we start here, then x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, we've said that, right? Okay, so the same thing is going to apply up here. And what we want to do is we want to match these ideas up. Okay, in this equation, a is equal to 3. In this equation, b is going to be equal to negative 2. Okay, we've got that b is equal to negative 2. Originally, in this original one, this is plus b. So here the b is negative 2. And here in this one, c equals 5. All right, so I know that A is going to equal 3, B is going to equal -2, and C is going to equal 5. So when you get one of these problems, you want to make sure that you write it in that basic form. So you've got your x squared term, and then your x term, and then your single term, and it's all set equal to 0. And then you look at what's the coefficient of the first term, that's A. The coefficient of the second term, that's B. And then that third term is C. And now all we're going to do is we're going to take these numbers and just plug them in here. Okay, so I have x equals negative B. Well, B right here is a -2. So negative B is just 2. Plus or minus the square root of B squared. Okay, B is -2. -2 squared is going to be 4. Minus 4 times A times C. So 4 times 3 times 5. Okay, I'm just plugging those numbers in place. And this is all divided by 2 times A, and A was equal to 3. Okay. Hopefully not as bad as it looked at first. All right, so now just as I work these things out, I'm going to get that x equals 2 plus or minus the square root of 4 minus 60 over 6. So x equals 2 plus or minus the square root of negative 56 over 6. All right. X equals 2 plus or minus, let's think about that 56, that negative 56. 56 is 4 times 14 times I. Remember, we're going to have that I now. That's how we're going to deal with the negative sign. The square root of 4 is going to be 2, right? So I get to pull that out. So I get x equals 2 plus or minus 2, the square root of 14I over 6. Okay, now the 2, and the 6 can all be divided by 2, right? So the 2 will cancel into a 1, the 2 will cancel into the 1, and the 6 will cancel into a 3. So I'm going to get this, write this as 1/3, x equals 1/3 plus or minus the square root of 14I over 3. So in reality, I have 2 answers. X is going to equal 1/3 plus the square root of 14I over 3. And X also equals 1/3 minus the square root of 14I over 3. Okay. All right, I only did one of those, and I got to kind of move on for you, so I'm not going to do another, but I think this is winds up being recorded. And so you'll see it again. So I can post that for you guys. But really, don't freak out over it. It's really not that bad. It really comes down to you take your equation, you line it up in the standard form, so you find out what is the value of A, of B, and of C, and just plug those in. Okay, so just plug those in. And remember the fact that this down here is plus or minus. Therefore, you have 2 different answers. You have the plus and you have the minus. Okay. All right. Let me do one other thing for you guys. We've got lesson 72. I just got a couple of things I want to go over there with you guys real quick. All right. Lesson 72 brings us back again to lines from experimental data. Okay. And if you wind up in your book looking for lesson 72, they wind up giving you a diagram, a chart where you have salt and you have carbon. Okay, and you've got this over here, you've got say 40, and then 80, and then 120, and 160. Okay, you see that? And then over here, 2, 4, 6. Okay, and they've given you all of these plots that they've put up through there. You kind of see these two different things that they've got going there. All right, and what they've got with this right here, you're going to wind up drawing two different lines that come through there. All right, as I've got all of that, I'm going to wind up drawing two different lines, and they've labeled for you. One of the lines is labeled is line A, and the other one is going to be line B. All right, so we do that, and we want to try and find a couple of points on these lines. So say I wind up looking over here on line A, and I'm able to identify a point right here, and say this point is 140, 10 on line A. And then let's say I find a point exactly over here on line B. Let's make it look a little more realistic. And this point is going to be 126. Okay, so I've got two different points there that I can look at. All right, so I've got those 2 points. I'm also going to have, notice the fact that these lines come down here and they kind of cross. And let's go ahead and get 2 more points on those lines as well. So over here on line A, I'm going to get a point that's going to be 0.61. And I'm going to get a point on B that's going to be 40. 0. So I've got 2 different lines. If you think about it, I've got, a line B and I have a line A. Okay. And I've plotted 2 points on those lines. On line A, I've got this 140, 10, and I've got down here this 61. And on B, I've got this point right here, 126. And I've got this point over here that's going to be 40 and 0. Good. Do you see that basically what we've done right there is just find 2 points on each of those lines? Okay. And with doing this, I want to be able to look at my graph and calculate my slope. Look here at the fact that A, I've got that 60 and 1. And then I've also got the 140. Hold on a second, sorry. Okay, yeah, up there. The 140 and 10. Okay, and then down here at B, there's these 2 other points. I have the 40 and the 0. Okay, and then I have the 120 and the 6. And you know how we would normally have X's and Y's, and we look at the X, the over on the X and the up in the Y to get our rise over run so we can figure out our slope. Okay, we're doing the same thing here. These figures right here are my carbon figures. Okay, those are going to be my carbon, and these are going to be my salt, just like I would have had the X and the Y. Instead, I have the carbon and the salt, and I'm able to still go ahead and figure out my slope there. All right, so let's think about the fact that here with this A, as I look at my 2 different points on my line, here on the y-axis, we've gone from the 1 to the 10, okay? And then on my x, I've gone from the 60 to the 40. All right, so I can think here about the A. I've got 10 minus 1. It's going to give me 9. And I've got the 140 minus 60. It's going to give me 80. Okay, looking at my slope, my rise over my run, right? Okay, so here this went from a 10. When I look at my Y position, I went from the 1 up to the 10, and on my across position, I went from the 60 over to the 40. So there's my rise over run. I found my slope right there. All right, and I can just divide those out and find that this slope is going to be equal to 0.1125. Okay, I can do the same thing with B. Okay, B went from 6 to 0, which is going to give me a 6. And it went from 120 to 40, which is going to give me 80. So there's going to be that slope right there. So the slope of this line is going to be 0.075. Okay, so I have my two lines and I know what my slope is. All right, so what they're looking for us to do is be able to find the equation of these two lines. All right, remember now with your the slope, remember y equals mx plus b, right? Okay, and in this right here, my y is salt. M is my slope. X is going to be my carbon, and then I'm still going to have my b like before, right? So what I'm going to do now, I'm looking for these two lines. So here's going to be the first one. It's going to be S equals MC plus B. And here's going to be this other one, S equals MC plus B. Okay, so with this first line, remember, this is my slope for line A. So I'm going to put that in here. S equals 0.1125 C plus B. All right, and then over here for this line, this is line A. This over here is line B. All right, so S equals 0.075 plus B. Okay, and then you're going to do the same thing that we've done before when we're trying to find the equation of a line. You're just going to choose points from the line and plug those point values in here. Okay, we already have 2 points on each of the lines, so I just need to pick one of those points for each of these lines and plug those values in. So here I'm going to choose this point for line A, where C is 60 and S is 1. Okay, and I'll plug in a 1 for the S equals 0.1125, and I plug in the 60 for the C, and I'm just going to be solving for B. And when I come down to the end, I'm going to get that B equals negative 5.75. So now I can write the equation of this line as S equals 0.1125 C. Okay, remember this was, this should be plus B. Yeah, and now my B value is minus 5.75. So this is the equation for the first line. All right, and you would do the same thing with that second line. You would put in the points. Okay, so as you look at these, they're going to give you all of these dots. You need to draw lines, okay? And then you just need to figure out what is the equation of that line. So you're going to draw your lines, and on your line, find 2 points, okay? Use those 2 points to determine rise over the run, so you've got your slope. And then take the coordinates for one of those points and plug those coordinates in so you can get your, see, I